So on 19 through 26 is the same as yesterday, basically. They just wrote it a little bit different. Use the Pythagorean theorem to find the missing side, and then do sine, cosine, and tangent of the angle they give you. No decimal answers on those. Okay, 27 is different because they're not even drawing a triangle. They're just telling us one fact. Cosine of A equals 5/13. Well, this is enough information to figure out something about a triangle, though. What does this tell us about our triangle? What's cosine supposed to tell us? Adjacent over hypotenuse. So if I made up a little triangle here, no, it probably wouldn't look like that, but that's okay. Pretend this makes sense. If I call this angle A, the adjacent side should be 5, and the hypotenuse should be 13. So this is the triangle we're using. Now, I didn't draw the picture very well. You guys remember this triangle for yesterday, 5 blank 13? 5 blank 13? Huh?
Oh.
It's number 9?
12.
5, 12, 13. Okay, so we could have done Pythagorean theorem, but anyway, it's 5, 12, 13 is one of those triangles that works out nicely. So they just want you to do the two other trig ratios. So we still need sine and tangent. So sine is, what sine tell us? Opposite and hypotenuse. And what's tangent tell us? Opposite adjacent. So 12 and 5. And that's it. (29) tangent of B equals 6. Okay, they got another curveball for us. What's that? Any ideas how we could unravel that mystery? Tangent's supposed to tell us opposite and adjacent. So what's opposite and adjacent here?
Where do you go?
What? Yeah, 6 and 1, right?
How do you know?
Because 6 is, what's 6 as a fraction? Okay, that's what I was seeing if you guys could figure out. So anyway, the opposite, I'll call it 6, and the adjacent, I'll call it 1. My picture doesn't look right at all. It doesn't really matter.
How do you know where to put them?
Opposite over adjacent.
Oh, so it always goes from the corner?
No, I could have done up here. It doesn't matter though, because it'll still be the opposite and adjacent, no matter where you put it. Anyway, 6 squared plus 1 squared would equal x squared up here. So 6 squared and 1 squared make 37. So this is going to be square root of 37. Alright, so sine of B is going to be opposite. Right. The square root of 37 kind of migrates to the top. Looks scary. Cosine of B is adjacent over hypotenuse. Yeah, 1 over square root of 37. If you multiply by square root of 37, it'd be square root of 37 over 37. The 1 kind of just disappears. All right. 31. Sketch triangle ABC. Okay, it's the same. You know, I don't really like these problems, but whatever. We're doing it anyway. Same idea. They just gave us a really messy decimal. So it's cosine of B. Kind of mean to us here. 0.8129. 92, rather. Okay, so here's the plan for this section. You guys watching? It's not a fraction, but you can think of it as a fraction if you put it over 1. So that's the trick. So this will be my adjacent, and this will be my hypotenuse. Got it? It's a mess. These don't represent the actual lengths of these sides, it just represents the ratio, and that's all we need is the ratio. So anyway, cosine tells me adjacent over hypotenuse. So adjacent is the messy thing, hypotenuse is 1. Now how can I find this guy? This squared plus this squared equals 1 squared. Or you could go backwards, this is kind of the fast forward version. 1 squared minus 0.8192 squared equals x squared.
How the frick?
You weren't watching.
I was watching, it doesn't make sense.
A squared plus b squared equals c squared.
But why is c squared not 1 squared?
It is. It's 1.
So which thing is that? 'Cause
It's a 1 because that's the hypotenuse right there.
yeah.
And that's 1 squared.
But why is
Oh, I just changed the order. Is that your problem? So it's 0.8192 squared plus x squared equals.
that's, I see what
I thought we'd already used this trick before. But I just kind of fast forward to the subtracting part. I just subtracted this.
okay.
And of course, because it's x squared, that means whatever comes out, you have to square root it. Maybe I should have stuck with the basics here. That'd been less confusing. What's that come out to? Some messy. We'll just go 4 decimal.
5735.
0.5735. Okay, so the sine of angle B would equal the opposite, that, over the hypotenuse, 1. So what's anything over 1 equal to?
So
Yeah, so it's just going to be, that over 1 is just equal to that. I'll go ahead and write it all down. 0.5735 over 1 equals 0.5735. And tangent is going to be a mess, so we're just going to have to use a calculator. Tangent equals opposite over adjacent. So just let your calculator sort that mess out. Just use the divide button. It'll be easier than the fraction button. Let's see, the book put 0.7001. You guys concur? Sure, okay. Okay, 33. This is kind of a foreshadowing of, well, I was going to say Monday's assignment, but it actually might happen on Wednesday because of the testing thing. So the triangles we're going to use, if you have a 45, 45, 90 triangle, like the angles are 45, 45, 90, the ratio of the two legs are going to be identical, 1 to 1. And the hypotenuse is square root 2. Where'd you get that from? Oh, have we already done this?
kind of.
I totally forgot.
Yeah, we kind of did that.
I totally forgot. Well, let's see if you guys remember this one then.
Isn't it like
All my classes kind of run together.
That's 1, that's 2, and that's square root 3.
Okay, yeah, anyways, we're supposed to do sine of 45 on number 33. So these only have one answer. And if you have a nice calculator, they can do sine of 45 without this, but if you have a kind of a basic calculator, you just need to use this picture. So sine is opposite over hypotenuse, right? So it's 1 over square root of 2, which is square root of 2 over 2. 35, last, no, 2 more. Tangent of 60. So tangent is opposite over adjacent, so opposite over 1, the adjacent. So it's just square root of 3. There didn't used to be calculators that can do this. And they only do, the nice ones only do it for the special triangles. It doesn't really work for the other ones. Cosine of 60 is adjacent over hypotenuse. 1 over 2.